Ladies and gentlemen, welcome back to my YouTube channel. It's Rishi, and today we are at part 3 of Form 3 Chapter 2 Standard Form. And in this video, we will be covering how to solve problems in regards to this chapter. Without any further ado, let's begin. Okay, before we start, I would highly recommend you to take out your calculator and do the calculations together with me. I will give you time, 5 seconds, or if you need more time, just pause the video at any moment to try out the questions by yourself. Remember, as Jim Quick said, practice makes progress. If you start doing it now, you will see some progress in the future. Alright, with that out of the way, let's begin. So, in this chapter, Standard Form, we do not get much of a variation in questions. All of the questions want you to make sure that the answer you give is in standard form or is in the form that they require you to make it in. That's about it. No worries if you don't understand what I'm trying to mean. As we go along these questions, you will start to get a feel for it. Okay, the first type of question is where they ask you to round off the numbers. So if you have not watched the first two videos, I would recommend you to watch it, because in those videos I have gone in depth on what is standard form and how it is used for you to have a context. So for the first question, A, we have 23,429, and they want us to round it off to two significant figures. So when you're seeing significant figures, always see it from the left. Always see from left to right. That's important. So in this number, there are no zeros, so we can safely assume that all of them are significant figures. And since they're asking us to make it into two significant figures, let's see from the left. So here we have the first one, which is 2, second one, which is 3, and they only want us to write down two significant figures. So let's go with 2 and 3. Before you write 3, make sure you check the number beside it to the right. So here, is this 4 more than 5 or less than 5, or it is 5? It is less than 5, so it will not be giving any additional 1 to the number in front of it, so we will add 0. So 3 plus 0 is 3, and then the rest of the numbers will become zeros. So yeah, I've mentioned in the previous video that in a whole number where there is no decimal, the zeros at the back are interchangeable between significant figures and non-significant figures. If you have no choice to make them significant figures, pardon me, let me repeat that. If you have no choice but to have them as significant figures, then you are completely allowed to do so. But in most cases, we would just regard them as non-significant figures. Alright, so for the first answer, it will be 23,000. That's it. Let's move on. B. So now we have a decimal number. No matter decimal or whole number, always see from the left to the right. What have I done here? It's not F, sorry. It's right. Okay. So for here, 0.2763. They want 3 significant figures. So as we can see, the 0 at the front is negligible. It is not a significant figure. Remember that. Zeros in front are completely neglected. Okay? So we have the first number here, which is 2. Second one is 7. Third one is 6. And since they just want 3 numbers, we can forego with the rest. So here we will have 0. Although 0 is not a significant figure, it's important for you to write it inside the answer. Just don't count it as a significant figure. So we have 0.27. Before you write down 6, remember to check the number beside it. So 3 is less than 5, so it will give plus 0 to the front. And you will have 6 plus 0, which is 6. 0.276. And remember, do not write a 0 at the back. You might say, how can you say that, Rishi? Because 1.0 and 1 are the same. So why can't I add a 0? Will it not mean the same? It will not mean the same because zeros after a decimal point, if they are the last digits of a decimal number, they are counted as a significant figure because they show how accurate a measurement tool is. In contrary to the first one, A, although we have zeros as the last digits, remember it's a whole number, not decimal. In decimals, you are not allowed to write 0 at the back because it will be counted as a significant figure. So in this instance, you will have 2760. All of these 4 digits are regarded as significant figures, which is wrong because they only ask us to write down 3. So you can just omit the 0 and take it out. So the answer for this question will be 0.276. Alright. Now let's move on to the next one. C, 10.235. This is quite tricky because they just want you to round it off to one significant figure. Again, look from the left, you have 1 here, and that's it. So what they want you to do is write 1. Before I write down 1, make sure the next digit is not 5 or more than 5. If it is, give 1 to the front. If it is not, just let it be. Just add 0. So you have 1 here, then you have 0 here. Okay. Do you have to write down decimal numbers? The numbers after decimal point? No. There is no need for you to write down because if you do write it down, you will exceed the required significant figure. You will go 3, 4, 5. But let's just keep it at 10. Now you might ask me, isn't this 2 significant figures because you have 0? As I told you in the first question in A, zeros in a whole number where there is no decimal point, they are interchangeable. If the zeros are at the end, they are interchangeable to become a non-significant figure or significant figure according to what you would like. So here we would like just 1. So let's just keep it as 1, and this zero will be regarded as a non-significant number. That's it. Now the last one, 501.723. So here, this is the first scenario where we have 0 in the middle of 2 significant numbers. Remember this, if 0 lies between 2 non-zero numbers, the 0 is automatically regarded as a significant figure. You will count it as significant figure. Alright? So here, we have 501.723. Same concept from the left to the right. 1, 2, and 3. And then you will write it down as 501. Before you write down 1, make sure you see the number beside it, 7. So 7 is more than 5, so we will add 1 to the front. So this plus 1 with the 1 will become 2. 502, and you stop right there because if you write down any decimal points, you will exceed the required significant number, which is 3. So we have 3 here, 3 numbers here, and let's just stop right there. That's it. This is how you round off numbers. I would recommend you to go through your textbook and do the questions yourself so that you will have a better understanding of it. Alright, now let's move on to the next question, number 2. So here we are dealing with some kind of arithmetic. We will be covering 2 types of these questions, and here we have different powers. And by the way, I will not be covering where we have two of the same powers because it's quite easy. I will be covering where you have different powers to the 10. So here we have 2.5 times 10 squared plus 1.35 times 10 to the power of 4. For this question, there are 2 methods, but I only showed you one method, which is easy, in the first video. So make sure you take a look at that video. So here what we have to do is, we will factorize 10 squared or 10 to the power 10 squared or 10 to the power of 4 out. Since 10 squared is smaller than 10 to the power of 4, we will take out 10 squared. Remember, this method only works if both of the powers are positive. So we will have 10 squared outside, And inside you will have 2.5. 2.5 plus 1.35. Since we have 4 here and we take out 2 of it, we will have 10 squared. If you are unclear of what I'm doing here, please polish up on your indices, because that's where this concept comes from. We have 10 squared. So following BODMAS, we have to do the times first. So 10 squared, which is 100. 1.35 times 100, you'll just have to move the decimal points 2 places to the right, then you will have 135. So with that in mind, 10 squared times 2.5 plus 135. Here, since we do not have any multiplication inside the bracket, we can straight away add them together. We will have 10 squared times 137.5. Alright, and you can change the format of writing into 137.5 times 10 squared. And remember, this is where most students make a mistake. They forget that they are doing standard form question and they do not change the answer back to standard form. Remember, in the first 2 videos, I emphasized that in standard form, the number must be less than 10 but more than 1. This number is 137. It is way beyond 10. So what you do is you bring the decimal point to the front. So you have 1.375. Then since you brought it in front too, so what happens is you have to times it by 10 to the power of 2 in order for it to go back. Remember? So we have 10 squared. Okay, 10 squared. And remember, this 10 squared is already there. So just write that 10 squared as well again. So same base times means you have to add them together. You have 1.375 times 10 to the power of 4. That's it. That's how you tackle this question. This method is not shown in the textbook. This is a method that I found easier to do when you just have positive integers as your power. Alright, now that we are done with this, let's move on to the next one. In the next question, I will be teaching you how you can do how to do the calculation based on your textbook's working steps. So what can you do is you take note of the negative integer which is lesser. So we have -2 and -5, and we know that -5 is lesser than -2. So here this is what you're going to do. You'll have 3.7 times 10 to the power of -2, and then minus 4.3 times. So for -5, we are going to break it down into 2 parts. One part must be the same as the bigger number, which is -2. So we're going to just write it down as 10 to the power of -2. And we know that -2 minus 3 will get you -5. So here, instead of writing 10 to the power of -5, you're going to write 10 to the power of -3. So mathematical wise, this is still correct, because if you times this together, you will still get 10 to the power of -5. We have just broken it down into 2. You may wonder, why do we have to do this? This is because we want to get 2 identical 10 to the power of 10 to the powers, so that we can mash them together to calculate them on paper. So here we have 3.7 times 10 to the power of -2, and then this 10 to the power of -2 will stay there, but this number 4.3 is going to be multiplied with 10 to the power of -3. This is in order for us to get rid of 10 to the power of -3 in the power form and make it into an ordinary number. So here, don't have to worry too much. Just take out your calculator and just type in 4.3 times 10 to the power of -3, which will get you 0.0043 times 10 to the power of negative 2 equals to, since you have the same power now for both sides, you can just take them together to 3.7 minus 0.0043 times 10 to the power of negative 2. If you're wondering what I've done here, I've just factorized it. Instead of traditional factorization where we put the factorized number in front, I'm putting it at the back. It's completely fine, you can do it both ways. It's still the same. So here we have 3.7 minus 0.0043, which will get me the answer of 3.6957 times 10 to the power of negative 2. And coincidentally, the answer is more than 1 and less than 10. So let's just leave it just like that. 3.6957 times 10 to the power of negative 2. Now, let's go to question number 4. And this is the last question. And in this question, we will be discussing how to apply this standard form concept across the solar system. So here we have Jupiter's diameter, 139,822. This might not be exact, but approximately. And then it's given in the question that surface area of a sphere, the formula is 4 pi r square times pi equals to 3.142. So for those who are new to this concept of sphere and circles, r refers to radius. Radius refers to the distance between the center of a circle to its circumference. In case of a sphere, from the center of the sphere to its surface, that's radius, that's r. And then we have pi, which is equivalent to 3.142. Assuming that Jupiter is a perfect sphere, calculate its surface area. We are assuming that Jupiter is a perfect sphere because Jupiter is not a perfect sphere. So for those who are astronomically inclined, most of our planets are not perfect circles or perfect spheres. Most of them are like, you know, American football, the football that's kind of like a rugby ball. It's, I think, the same thing. Not the same thing, sorry. The shape is quite similar. Sorry. So all of our planets are not exactly sphere. They are a bit oval shaped, but let's not get into that too much. But assuming, for this question, assuming that Jupiter is a perfect sphere, to calculate its surface area, we just have to plug the number inside the formula. We have 4 pi r squared. And let's just sub all of the terms, all of the numbers inside. So we have 4 here, 4 times pi is given 3.142, and r is not given, but instead of radius, they've given us diameter. For those who do not know what is diameter, diameter is the distance between 2 points in the circumference that passes through the center. So mathematically, diameter is the value of 2 radius. So 2r is equivalent to diameter. Since if we just want the radius, so what we have to do is diameter divided by 2. So just get the number 139,822 divided by 2, then square it. This whole thing can be done inside the calculator, so please do not beat yourself or beat your brain up to find the answer mentally. No worries, just use your calculator. So we have 4 times 3.142 times in bracket 139,822 divided by 2, and then square it. You will get the number already in standard form. So you have 6.143 3 times 10 to the power of 10. For those who are asking, how do I know which decimal point to stop? This is something that is completely up to your school teachers. So remember to ask your school teacher how many decimal numbers or how many significant figures that should be in your answer. Because for different teachers, the requirement is different. But for SPM, it is often enough to just write down 4 significant figures. And if you want to be extra careful, 4 decimal points are also allowed. It's completely up to you. Okay, so we have 10 to the power of 10, and take note that the number that you have gotten is less than 10 and more than 1. In that case, you're completely good to go. But if you do not get the answer in this form, make sure you tweak it a bit so that the answer is between 1 and 10. That's all the questions we have for this chapter and for this video. And if you have any questions, feel free to put it in the comment section below, or send me an email through the email address that I have put down in the description box. As usual, thanks for watching, and until the next time, bye bye.